Alright, so what you'll see in today's video is going to be a very useful tutorial. It's for creating utility scripts, something like this, where we have the diameter that we can change of this spiral. We have the multiplier of how many spirals it creates, the quality, we can increase and decrease this, also changing the direction of that spiral, and then turning it into a cluster. So when we double click it here, you'll see all the steps that we went through to create that. But what's even more useful in my opinion is being able to set any line segment like this one and be able to create that spiral using that base geometry. So hopefully you're excited to see what this is all about. I'll be going over all of the steps in detail from beginning to this location in this spot. So thank you for being here, and let's jump right in.
Plug it in, generate, iterate.
All right, so to start here, I want to show you a few things because inside of Rhino, there's a command called spiral. So if I go here and I type in spiral, you'll see that there's a command and it goes through the options of creating a spiral. So the first is the first point. We'll just start here at 0, and then we can change all of the parameters within this command to create a spiral. But the thing is that when you go into Rhino, so let's go here, or into Grasshopper, and we type in a spiral, there is no spiral component within Grasshopper. So what I'll be showing you now is how we can get started and create that ourselves using the same inputs that you would see within Rhino. So it says diameter, mode, number of turns, 10, then pitch, and so you can also reverse a twist. So we'll make sure to be able to create all of those capabilities so we can create it using just one base point. So now let's do that, and let's get into how we can create some of the things that we have within Rhino parametrically. All right, so for this one, I'm going to just create a line segment here in Rhino. And with this line segment, we can get started with the whole script. So, and the reason for that is I think the best capability to do this is going to be using a line segment as the base geometry. So let's go here into Grasshopper. We'll bring in a curve component. We will make sure that this is selected and then go here to set one curve. So now that we have this, let's now create the reference plane to create the spiral. So now that we have this line segment, we're going to bring in a perpendicular frame. So with this component, we're going to plug in the curve as the input, and the parameter is going to be where along that line segment we're going to have the frame or the construction plane. So we'll go here to parameter 0. We want to have this right at the beginning because the script is going to be based off of this plane input. So now that we have this, let's go to a circle component. And when we use a circle component, we're going to have two inputs. The frame, which is going to be that construction plane. The radius, which is going to be how large the circle is going to be. But the idea is to have the overall size, so we want the diameter, and so let's go here to 50. If we plug in 50 into the radius, this is actually going to be 100 for the diameter, so we'll need to do 50 divided by 2. This way we have 25 as the radius, and 50 is going to be the diameter. Next, we're going to be taking this frame or this construction plane and deconstructing it because we need to know the X, the Y, and the Z directions relative to that plane. So we'll go here to deconstruct plane. This origin point, we're going to extract it. So when we have a component like this, we're going to have various outputs, but sometimes we just want to use one of them. And so it's a good way to stay organized and extract it with this point component. Now what we're going to do is move it either in the X relative to this plane or in the Y direction relative to this plane. So we're going to bring in an amplitude component, which will let us set an amplitude or a magnitude for, say, the X direction. And now we're going to be taking this point and moving it relative to that plane. So we'll use the point as the input, the motion as the vector, and the amplitude is going to be as the magnitude, or how much it's going to move by. And so for that, we're going to be using the radius. So we'll use 25. So now we have the capability of taking this line segment and we can move it around, and we'll see that no matter where we place it, that spiral is going to be created relative to the perpendicular frame created at the start here. So with this, now we're going to be just create another line segment here. So it's this. Now the line segment is going to determine the height of it or the length of it. So for now, we're going to take this point and move it in the Z direction relative to that plane. So now we'll go to a move component, copy this one again. We'll copy the amplitude vector and use the Z direction with a new slider. So I'm just copying some of the components here. It just makes it a little bit more efficient in terms of workflow. And I also want to show you the way that I do things here. So let's go here to the maximum being the length of this. Now we have to take that line segment and evaluate its length. So we'll go here to length component. And I will double click here on the output of the curve. So we know that all of the outputs are coming out from this curve into this relay and from this relay into the curve input. So now the length is going to be the amplitude or the magnitude of the movement of that point. And we have this vector, which geometry is going to be the point. And this is going to be the vector. So no matter how far we bring this out, it's always going to be putting that point at the end because it's determining that by where the length of that line segment is, and it will always move that far. So we're going to be doing the same thing with the point that we moved here. But notice now that what we need to do is create a series of copies here to be able to then rotate them and create the twist. So to do that, we're going to take this point and we're going to move it in the Z direction and using a series component. And the series component allows us to set more than one number as an output, as compared to a slider here, which it only has one. So now let's set the step, which is by how much it's going to step. So we'll just say 1.5 here for the step. And the count, we'll just say 20. Notice though that it won't allow us to, we want to be perfect right to the end here. So there are different ways we could do this. We can either select this point that we moved and this point, create a line segment between the two. I'll hide this one because we don't need it right now. Now we are going to take this one and this one. Create a line segment between the two. And divide that line segment by a specific number. So we'll go here to 20 and then divide curve. So now that we have all of these points, there's another way of doing it is using series, and it's using the length. So we know the length is going to be the max number and then divided by a specific number. So let me show you this other way of doing it. So using the length divided by how many times we want to copy this. So the length divided by 50. So we need a step, wow, let's do less of them. We need a step of 3.79, and we need 20 of them to create the length. The division component here is going to be useful because we can now move it a series of times. Using this input. Now, the only thing is that we need one more because it's only going to be creating 20 points, but the 20 points are divided by the length. So we actually need to go here +1. And then it'll create that last one because it's doing the divisions in between. And so this adds that last one. So these are two different ways of doing it, is dividing it by dividing the line segment or dividing it by dividing the length by the number. I'll be deleting this one because it's a little bit more efficient to do it this way. So now that we have this, we are now going to rotate all of those points using a series component. So rotate them one at a time, depending on how many we have. So if we look here at the points, we have 40. So even though we have 39 divisions, we actually have 40 points. That's because we have the first one and then we have the last one. So it's going to add one more. Now we need to rotate it. So we'll go here to a rotate component. And if we rotate all of these points relative to the original plane, because we know that this is what we're working with, and we only have one number. So if you see an angle here, I'm going to change it to degrees. And if I said 15 degrees, well, it's going to rotate all of them at once. And we want them to rotate one at a time. So what we need to do is bring in a series component. And in the same way that I showed you earlier that you can divide using the length and the number of objects you want, well, we can do the same thing here, but this time it's going to be using 360 degrees, which makes a whole circle, divided by how many rotations we want. So we want here the length, how many points we have. So how do we do this? Well, we know that we have 40 points, and every time we move this slider is going to have a different number. So now we'll bring in a list length, which will let us know how many objects we have in this component. So this is really useful because every time it changes, you'll see that this will give you a number as the output of how many things are input into this component. So now I'll use 360 divided by, let's lower this just to make it a little bit easier. 360 divided by 21, which means that they all need to be rotated stepping by 17. So that's going to be the step. Now the count, well, it's going to be 21 of them. And so now we have the first one being 0, then stepping by 17, 34, and it will step progressively until it reaches 21 points. So now we can use the series component as the angle input. And notice that it creates a spiral all the way to the end. Now notice though that when we see the output here, we have 21, but when we select this, we don't have the last point here. We actually have the last point before. So what we need to do is go to list length here, the 21 plus 1. And that closes it off. Now, the thing is that we need to have that starting so the start point is going to be at a different location, but if we change the start point to be there, then we need to have the step be -1. So length 21 -1 or +1. So here it's actually, well, kind of messed up showing you this part, but that's okay. So the length has to be 21 -1, which makes it 20. So it divides it by 20. And so it rotates this evenly from beginning to end. So that is the only part that's a bit strange about subdivisions and rotations here, is that we actually want 21 rotations, but we need them to step by one number less so that it rotates all of them evenly. Now, if we increase the subdivisions, well, that's just going to increase the quality of your spiral. So just keep that in mind. This is 100. We'll go here to 200. I'll disable the preview on this part. And if I lost you somewhere, I'll have this available as well. I'll delete this point for now because we don't need it. And I will use a plane input, which means a reference construction plane will be put in here from all the way over here. And I'll just hide the wire display and bring this over here so we know that we have a plane input, but we don't have to see it be routed all the way from the beginning to this portion. If you're seeing things a little bit different than what you see in your Grasshopper script, make sure you also have display, draw icons, draw fancy wires, and draw full names. That's how I have my script laid out here. Also, amplitude here, this length one, I think we can clean it up like this. I just don't like overlapping wires if I can avoid it. And this circle is not necessary, but it serves as a guide so you know how big the spiral is going to be. So now let's move this around. Let's see if it still holds true. It does. So I'm going to undo it back to this location. Okay. So now let's take those points and let's bring them together using an interpolated curve, which means that this line segment will be created going through all of those points. Now, this is just one twist going all the way around. And if we actually look at this from an elevation view, it creates a sign. And if we look at it from the front, it creates a circle. So what we need to do now is multiply how many times this is done. And so what we need to do is take 360. So let's move this down. And multiply it. That's the division. Let's go to multiply. When you bring in the star or multiplication, what is it, a character? It'll create a multiplication here. And now we can use 360 as A, and B is going to be the multiplier. So if we want this to be multiplied 3 times, it'll be 360 times 3, 1080. Now we can use this as the input. So this multiplier will be the multiplications of how many times we want that created. And the subdivisions are going to determine the quality of that spiral. So now we can increase this to, let's say, 500. And it will make the curve, when you lower the number, you'll start losing the quality. So when you increase to more points, you have more points for the curve to interpolate, and therefore make it a more accurate curve. Let's change this to 1,000. Okay, so this is going to be the slider that determines the quality of that spiral. And now we'll take this and go to a curve component. So we'll use this as the output. Now, when we have the angle being a positive number, then if we want to multiply it by, want it to go the opposite direction, we would actually bring in a negative component and switch the orientation of that. So how can we do this using some sliders? Well, we can take the series and multiply it between 1 and -1, right? So if we take all the numbers and we multiply them by 1, they stay the same. If we multiply them by -1, then they will change. So we'll go here to a list, value list. And this one is really useful because we can just have 2 different inputs. But notice how it works here. When you do the drop-down menu, you have 1, 2, 3, and 4. And how do we change that? So when you double-click on this, it says 1, 2, 3, and 4. So that is what is displayed here in the value list, is what is before the equal sign. And what's after the equal sign is actually what will be output from here. So if you look at the output, and we bring in a panel, so quotation marks. 1 is 1, 2 is 2, 3 is 3, and 4 going to be 4. But here they're shown different way. 2 minus 1, 2 squared minus 1, and then square root of 16. So all of those, I can change that. Let's say 2 and 3 to be 10, and then 4 to be 20. And now 4 is 20, 3 is 10, 2 is 2, and 1 is 1. So this is really useful because now we're going to go in here and say no rotation or flip, and then flip, and then flip 2. And so we'll do 1 and then -1. So original, or we'll call this clockwise, counterclockwise. So clockwise is going to be 1 because if we multiply by 1, then the numbers stay the same. And counterclockwise is going to be -1 because if we wanted to go in the opposite direction, we want it to be a negative. So if we multiply all the numbers by -1, we'll have negative numbers. So let's do that. Series numbers into the A input. So here we're going, didn't save it. This one is going to be clockwise, counterclockwise. We'll hit OK. So now we have two options, clockwise and counterclockwise. And then here we'll have flip direction. So let's do that again. The input is going to be 7 multiplied by 1, which equals the first one's going to be 7. And if we go counterclockwise, then opposite direction is going to be by a negative number. Oh, not 2. It's going to be -1. It just didn't save it before. So now here is going to be -7. So we'll take this, plug it in, and this will now serve as the flipping of the direction of the twist. So let's hide all the points. Let's hide the line segment. Let's hide the original points. And let's take this and move it to the end location. So we have a start circle and an end circle as a reference. Moving it using this one. So now these two are going to be reference curves. So I'll plug both of these into a curve output. Plug those into a relay or double click on the input to create the relay, and then bring this over back here and hide the display. So now we have this one. I like to group it, and then we can call these reference circles. And this is going to be the twist or the spiral. And now we can hide all of the inputs and check and test to see if this works. So depending on the length of this line segment, we've now automated the way to create a spiral using Grasshopper. And now we can turn this into a cluster, which will make it a lot easier for us to use this again. And this will actually be on the new portion of my site called Utility Scripts, where I'm going to be sharing more scripts that are not necessarily full designs, but are useful utility things that you can use within Grasshopper to create other designs. Like with this, you can create a spiral staircase, you can create a spiral ramp. So there are other applications using just this, but this will make it so you understand that you can use Grasshopper for many different things to create shorter, smaller scripts that you can then apply for other things, but you can also make it and use it to create full designs. So with that being said, let's take this, double click on the input to create a relay. This is going to be a component, so I'll group it. I'll take this one, I'll group it. I'll take the number, this is the quality, so let's label this. And this is going to be the diameter. This one, it's going to be a consistent always at the beginning. So I'll right click here and go to internalize data. And this is going to be the curve input. Okay, so what I'll do now is I'll save this as a script because it's good for me to have this to share with you guys. And also in general, I like to have the scripts before I turn them into a cluster separate to always be able to come back and change things or add things to this. And so then after that, then we'll change it into a cluster. All right, so now that I have that saved, let's turn this into a cluster. So what's important about a cluster is that things that show up in your cluster are organized from up to down. So wherever you have your slider, but more importantly, your input, that's where you're going to see it within the script. So what I like to do is bring the inputs to the left-hand side. So the diameter is a critical one. I'll bring it right next to this one. This is going to be the multiplier. This is going to be a critical one as well. And then I like to use the quality one. That's a good one. And then usually my value lists go towards the bottom. Now sometimes if you do it this way, it's not going to matter whether your input is below or above one or another, because what I'll do now is double click here on the output for the sliders and for the value list. And now we have them organized this way. So this is going to be the first one in the component. This is the second one, and so on. We can always come back into the cluster and add more inputs and more outputs and even continue the design. And so that's something to be aware of, is putting it into a cluster does not completely ruin the design or finalize it in a way that you can't re-edit it. It actually makes it very useful because you can always come back and edit any part of the design or even alter it however you want. So now we'll take this, the inputs, the outputs, and everything in between, middle click, and then this is going to be the cluster. So convert all selected objects into a cluster. What that does is it turns it into a component where the entire script is contained in here. And now we have this as the output and this as the output. And if you don't want them to be grouped, we can now ungroup it and you can label it here. So you have to make sure you right click very close to the end. And this is going to be the spiral. And this is going to be the reference. I will hide the wire display on this one as well. Now we'll bring this all the way over here and ungroup these as well. I like to organize them like this. So I'll select all of the inputs, go to this align to the right, and then get them closer, select them, and then when you use this middle one, it's going to evenly distribute it. Now, if we take this input and we delete it, this is going to turn orange, which means that it has nothing inside of it. So now let's use a different line segment. Go to set one curve. Let's change the multiplier. So I'll actually increase this to a larger number. So in Rhino, it's asking for the start and end axis for creating the spiral. But I think it's even, I don't know, I think it's pretty useful to be able to do it with the curve input, going in any direction. So I'll be definitely using this script again for other purposes. Now, what I like to do is when I share this with you, I want you to be able to open this and already have something working. So this is why you'll catch me already creating a parametric line segment. So I'll bring in an SDL, a line segment with the start, direction, and the length. I'll go to the direction and the Z direction. The start point would be using construct point. And the length, we'll just say 50. So now we have this parametric line segment that we can unplug, or we can just use a different curve component, set it here, and then bring it into this one. So this is kind of like an empty one that we can undo it and then set one curve. But I do like to have that, like I said, plugged in and ready to go for those of you who want to have this ready. So I've shown you from the beginning, creating the base geometry, rotating the points, creating the spiral, then turning it into a small cluster that you can use over and over again and even share with people. So thank you very much for being here. Hopefully you found this useful and learned a few more tips and tricks, and I hope to see you in the next video.